Okay, good morning. This is Professor David J. De Los Reyes. It's September 10, 2023. The time is 3:09 a.m. Okay, my next session for this morning will be what's this? College Algebra, lesson number 57. We are running smooth on college algebra and we are almost done with the syllabus of college algebra. Okay, let's proceed. The title of the topic will be, or the discussion will be college algebra, lesson number 57. We are running smooth, okay? And the title of the topic will be binomial theorem problems. So we will be solving problems on using binomial theorem. And actually, there are two kinds of solution. It is by using Pascal's triangle or by using the so-called factorial notation or just simply factorial. Okay, again, for tonight, we will be solving an actual problem. Okay, it's not x and y, it's a pure number. Okay, and we'll try to see if the expansion will be the same for both the Pascal's and the factorial solution. Okay, this will be the problem. Example, so we are solving problems. Expand the given binomial 24 plus 12 raised to the fourth power equal to. Oh, this is a binomial number, right? Two numbers inside the quantity, and we are to expand. Oh, I will not make the exponent too long, too high. I will just be 4, so we could visualize what we are doing. Okay. Solution number 1 by using Pascal's triangle. Pascal's triangle, even if you are sleeping, actually we could draw the Pascal's triangle. Okay, let's draw the Pascal's triangle. The top point will be 1. Next one will be 1 and 1. Next row will be 1, 2 and 1. Why 2? The 1 plus 1 is 2, right? So the 2 par ends will be 1 and 1. Next row. The 2 par ends are 1. The two middle terms will be 1 plus 2 is 3 and 2 plus 1 is 3. That is for n is equal to 3. Next one. The 2 par ends are again 1. Okay, there will be 5 terms, so 3 terms inside. So the coefficients inside it will be 1 plus 3 is 4, 3 plus 3 is 6, and 3 is 1 is 4. The 2 par ends are actually 1. And that is actually what is needed in the solution of the problem. Because the given problem, n is equal to 4. Right? So meaning to say, after constructing the Pascal's triangle, what comes out on the Pascal's triangle are actually the coefficients of the expansion. So meaning to say, the coefficient of the first one will be 1, so this is 1. The coefficient of the second one will be 4, this is 4. The coefficient of the third one will be, where is it? It is 6. The coefficient of the fourth one will be 4. Okay? And the coefficient of the last one will be 1. Okay? So this is 1 corresponds to this, 4 corresponds to this, 6 corresponds to this, 4 corresponds to this, and 1 corresponds to the last one. Okay? And for the binomial terms, okay, it's easy. The powers of the first term should be in the so-called descending order, and the powers of the second term is actually in the ascending order. So for the first term is 24. It will start with 4, next one will be 3, next one will be 2, next one will be 1, and the last part is actually 0. So it goes down from 4, 3 to 1, the last part is 0 for the exponent of the first term. For the second term, the exponent actually in the so-called ascending order, it will rise up. So it will start, the second term is actually 12, right? So it will start with 0, it goes to 1, it goes to 2, it goes to 3, and the last one, it goes to 4. Okay? So after expanding the two terms, okay, and we know the coefficient, okay, we go simplification. But take note that 12 to the first power will be 1. Okay? And 24 to the 0 power is also 1. So actually, the first and last terms, it is just the value of the first term to the fourth power, and the last term is the value of the second term to the fourth power. It is actually this. Where is it? This is. Oh, that is by using factorial. But I just show you that the expansion of the first and last will be the first to the fourth, second to the fourth. Okay? Oh, let's try to simplify the three middle terms because there are three middle terms. This is with the coefficient 4, 6, and 4. Okay? So if we now try to simplify, so use your calculator over here. Okay? 24 to the fourth is actually 331,776. Right? And this value here, okay? It's easy to do that one. I will give you one example. It will be 12 cube is 1728, right? 1728. This one. Times 24. Times 4. Okay? And the value, where is it? The value of this actually this one. It's 165,388. It is this. Right? That's the second to the last. This one. For this one, where is it? Second one. This one here is actually this. And this one will be 497,000. The second to the last will be 165,388. And 12 to the fourth power is actually 20,736. And if we try to add all these ones, I did it myself by using my scientific calculator. It's a Texas scientific calculator, just a simple one, not the programmable one. I don't even need the programmable one. The expansion of the given binomial numbers 24 plus 12 to the fourth power is 1,679,616, and that will be our answer. Okay? And to check this value here, what's 24 plus 12? That's 36, right? And the problem is just asking what will be 36 to the fourth power. This is y to the x fourth power equals, okay, this is 7 digit. 1,679,616. It's the same as the solution, or it's the same as the answer using the binomial solution using the Pascal's triangle. So if we try to do use this or expand this using the calculator, 1,679,616, same as this one. Hallelujah. Okay. Solution number 2. Solution number 2 is by using factorial, just simply factorial. Okay, well, let's try to bring out the formula and how to expand the binomial terms using factorial. It is this. Originally, our representation was actually a and b inside, right? So a plus b raised to n. Okay. This should be the coefficient of the first term times e to the n. Coefficient of the first term, or second term rather. Okay. Raised to, if this is 1, this should be n minus 1, and this is 1. The coefficient of the next one will be n and 2. You see, it's increasing n1, n2, right? So if this is 2, the exponent of the first term will be n minus 2, and the second term will be b squared, and so on. And to compute for the coefficient in each of the terms, the formula is this one. This is the formula. right? This is my first time to see a subscript in front. So subscript N, capital letter C, subscript R. The meaning of this, it will be the coefficient of the expansion by using factorial. And the formula for taking this is actually n factorial over r factorial times the quantity n minus r. This is factorial. That's the formula. So if we try to expand this, 24 plus 12 to the fourth will be, okay, we know that the first and last part is actually just raise the first one to the fourth power, just raise the second one to the fourth power. So I write it here already. This is the first one. This is the second one. So our only problem now will be from N1, N2, and N3. The next one is N3. Or N3. Okay? So the next one will be, okay, coefficient 4 and 1. What will be next? We start with 4 with the first one. Actually, this is the second term. So this will be 24 to the third power, 12 to the first power. 3 plus 1 is 4, and it is equal to 4. That's the second term actually. First term, the last term, this is the second term. I just write the last term following the first term. So we will be segregating the calculation, right? Next one is the coefficient 4 and 2. Okay, this is 3. So this will now be 24 square, 12 square. And the third term inside, okay, that is with the coefficient 4 actually. This is 4 and 3 coefficient, 24. This is 2, right? So what will be next will be 1, the exponent of the first term, and the exponent of the second term will be 3. So 1 plus 3 will still be 4. So at any moment, the exponent of the first and second terms is actually equal to the given exponent. 3 plus 1 is 4, 2 plus 2 is 4, 1 and 3 is 4. Okay? Then we try to, what you call this, solve the simplification separately. Okay? So I place it here now. I will compute for the value of this separately. That's 331,776 by using the calculator. 12 to the fourth is actually the last term, right? I just write it just after the first term. 12 to the fourth is actually 20,736. Then solving the individual coefficients. The individual coefficients are actually 4 and 1. If we try to simplify, 4 and 2 and 4 and 3, it is by using this equation here. Right? So solving coefficients. For the coefficient 4 and 1, by following this equation here, if this is 4 and this is 1, this should be 4 factorial. R is actually 1, so this should be 1 factorial. This one here is n minus r. So 4 minus 1, this should be 3 factorial. Right? So we are following this. This is the top one is n, and this is r on the formula. So 4 factorial will be 4 times 3 times 2 times 1. Am I still on camera? Okay. All over 1 factorial is just 1. 3 factorial is 3 times 2 times 1. Okay. Then try to make some cancellations. We can make cancellations because the operation on both the numerator and denominator are all multiplications. We are free to cancel, right? So these 3 here cancel with this, these 2 here cancel with this. Of course, 1 and 1 cancels. What remains for the coefficient 4 and 1 will be 4. Okay? 4 and 2, this should be 4 factorial. R will be 2, so this is 2 factorial. We're following this. N minus R will be 2, right? So this will be 2 factorial. Simplifying this one, 4 times 3 times 2 times 1, same as the first one. 2 factorial is 2 times 1. 2 factorial is again 2 times 1. Okay, then try to make some cancellation. I'm repeating it. This is algebra. Okay? If the operation in both the numerator and denominator are all multiplication, we are free to cancel. Okay? So this 4 here cancel with this 2 and 2. Right? 1 in 1 will be 1 on the numerator. We are free with that one. So what remains will be 3 times 2. The next coefficient will be 6. Because this one here is actually this. Right? And this one here is actually this one. So under Pascal's and factorial, it's coming out that the coefficient as per calculation are the same, right? This 4 here refers to this. This 6 here refers to this. Let us see if the next one will be 4. The coefficient 4 and 3, it will be 4 factorial. Okay, r is 3, so this should be 3 factorial. 4 minus 3 will be 1, so this is 1 factorial. Simplifying this one, 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 1 factorial is just 1. Okay, then try to make some cancellations. This is 6. 3 and 2 will be 6, right? 3 and 2 will be 6. 4 times 1 will be 1 over 1. So what comes out is 4. So this 4 here is actually equal to this. Right? And we have computed already the first term and second term. We know the coefficient. So simplifying now, where's it? We are following this. 24 square is 331,776. 12 is 12 to the no, to the fourth. 12 to the fourth is 20,736. Okay? Actually, in the given equation, the simplified equivalent of 24 cube and 12 is I just represent that as x. And the simplification of 24 square times 12 square, I represent that as y. And the product of 24 times 12 cube, I represent that as z. Okay, before I will go with this, I computed x, y, and z separately also. These are the values. X is 165,888, y will be 82,944, and z will be 41,472. Z is actually the product of 24 times 12 cube. Y is the value of 24 square and 12 square. And x is actually 24 cube times 12. Okay? So after computing this one separately also, it is now just mere substitution back here. So this is the first part. This is actually the last term. We are here now. The coefficient 4 and 1, as per our computation, it is 4, right? So this is 4. Okay, and this is represented by x. This is multiplied by 16588. Okay, 4 and 2 coefficient is actually 6. This is 6. It is 6. So this is 6. And the product of 24 square and 12 square is actually 82,944. Right? It's nice to compute if you are systematic. Then the last part, the coefficient 4 and 3 is actually 4, right? So this is 4. And the value of z is actually 24 times 12 cube is 41,472. 41,472. If we try to simplify this one by using our calculator, okay, I repeat this one. The third one will be this. Fourth one will be this. Okay. The third one inside is 165,888. So if we try to add this one, the summation will be 1,679,660. Okay, I will try to show you. So you believe in me, right? So just give me 1 minute. 331,776 plus 20,736 plus 663,552 plus 497,664. The last part is plus 165,888 equals. The value is 1,679,616. 1,679,616. Hallelujah. This answer here is the same as the answer by using Pascal's triangle. That's it, guys. Okay, this is Professor David J. De Los Reyes from Los Angeles. This is a topic on the expansion of a binomial terms by using Pascal's and by using factorial notation. Okay, good morning from Los Angeles.